Okay, on to the next page. So there's a lot of information here that you need to, prior information that you need to bring from grade 11. But just to quickly review, when we figure out the ratios for a given angle, we have to remember SOHCAHTOA. So some other things you need to remember here is that sine, right? SOHCAHTOA. So remember, sine of an angle is opposite over hypotenuse, cosine of an angle is adjacent over hypotenuse, and tan of a given angle is my opposite over adjacent. You also need to remember the reciprocals of these. Okay, so the reciprocal, and I don't have enough space. So the reciprocal of sine is cosecant, and it is the reciprocal. So I'm just flipping the fraction here. I'm taking the reciprocal of the fraction. And then the reciprocal of cosine, okay, is going to be secant, which is hypotenuse over adjacent. And then the last one here, tan, the reciprocal of tan is cotangent of an angle. And so cotangent, the reciprocal would be adjacent over opposite. We also have to remember our special triangles from last year. So the special triangles from last year were the 45s. So if we do the math on this, 45 degrees, I'm going to just bring this over here. Okay, 45 degrees times pi over 180 is equivalent to, well, there's 4 45s and 180, so it's equivalent to the pi over 4. So the pi over 4 is the related acute angle of 45 degrees. Coming over here, so this here, this triangle, using the side lengths of 1 over 1 and root 2, this root 2 is found by, again, the Pythagorean theorem. We can use SOHCAHTOA to figure out the ratios given the side lengths. Coming over here is our other special triangle. So pi over 3, if you do that calculation, right? So if we take so if you remember, it went 1, 2, root 3, and then we had down here a 60 degree and a 30 degree. And so if you look at 60 degrees first, 60 degrees times pi over 180 does reduce to pi over 3, okay? So there's your 60 degree right here. I'll put them on here, 60 degree, 45 degree, and then this is your 30 degree, pi over 6. Okay, so that's your new special triangle working in radians. We also talked about the special angles, okay, and these fell on the X and Y axes. And so just to review, I'm going to add on here. If you had theta is equal to, so you're on the 180s. So this was on the 180s, so 180 degrees times n. And n was an element of integers, and theta was element of real numbers. Okay, that we found that, okay, so just to back it up here, when we're talking about, make sure you guys can see that. Bring this up just a little bit. Okay, so when you're on the 180s, we're talking about the x-axes, okay? X-axes here and here. So these are your zeros, or 0 and 2 pi. So 0, 2 pi, you can even do 4 pi, right? And then on this other side, this is your pi, 3 pi, and so on. So when you're on the 180s, or in this case on the pi's, okay, when you go to do sine of pi, for example, it's equal to 0. Cosine is plus or minus depending on which side you're on. So we're on the positive side. So positive if you have cos of 0, 2 pi, 4 pi, or so on. So multiples of 360. And then we're negative for cosine when we're multiples of 180. So pi, 3 pi, 5 pi, and so on. Now for the next one, when theta is equal to, this is your 90 degrees, so 90 degree plus 180 degrees. So now we're on the y-axis, and n is an element of integer and theta is an element of real numbers. So let's just graph that one down here. So we're on the y-axis. There we go, right there. Okay, so for example, if you're on the y-axis, like pi over 2, which is 90 degrees, or the next one after that, if I add 2 pi, that's going to be 5 pi over 2, and so on, right? That's a positive y value. When you're doing sine of pi over 2, it's going to equal positive 1. When you're doing sine of 5 pi over 2, it's still on the positive side of y. It's going to equal positive 1. Now, if you're down here at the bottom, so I'm adding 180 degrees. So I'm adding pi. So for example, 90 would be pi over 2 plus pi. That's going to give me, let me do that math here, 2 plus 1, so 3 pi over 2. So coming over here, this would be 3 pi over 2, or 270 degrees. If I add another 2 pi onto that, I'm adding 4, so that's 7 pi onto 7 pi over 2. And so when you're multiples of this, and you're doing sine, let's say sine of 270, or in radian, 2 pi over 2, or sine of 7 pi over 2, we're always going to get that negative 1 because the y-axis here is a negative value. What else? Oh my goodness, there is so much more information. Let's go up here, the cast rule. So we also have to integrate the cast rule. So if you can remember back, all of the ratios in the first quadrant are all positive. So what that means is if I take the ratio of sine of an angle, it's going to be greater than 0. Cosine of the angle is greater than 0. And tan of my given angle, the ratio will be greater than 0. It's going to be a positive value. Let me see if I can zoom in here a little bit more. There we go. If I'm in the second quadrant, only sine is going to be a positive. So sine of its angle is greater than 0. As well, remember the reciprocals are also positive in these quadrants. So sine and, in this case, cosecant will be greater than 0. When you're in, I'll go down here. When you're in tan, the third quadrant, so tan of theta will be greater than 0. The ratio will be greater than 0, and it's reciprocal, so cotangent of the angle will be greater than 0. And lastly, when you're in the fourth quadrant with C, cosine is greater than 0. The ratio, the cosine of an angle, so we're talking about the ratio, is greater than 0. And then lastly, it's reciprocal, so that would be secant of the angle is greater than 0. Okay, and then just as a reminder, all means even the reciprocals are a positive. So let's go down and do some examples. So I'm going to stop the video. I'm going to move my page and we'll do some examples.